So guys, in this video we are going to code the problem that is vertical width of the binary tree available on Geeks for Geeks platform. So this is our main function, public int vertical width. Okay, so first we are going to deal with the edge cases here. So what are they going to be? That if root is equal to null, what we are going to do? We are going to simply return 0. Okay, now we are going to create a left array which will provide us with the location of the leftmost um, node in this binary tree. So it will be nothing but int left basically, which we will initialize with 0. Okay, similarly the same thing we are going to do for the right. We will create an array right, initialize it to 0, which will give us the location of the rightmost node, and our root node will be at 0. So we have understood it in the problem statement video that the scaling will be something like that our root node will be 0 at 0, and whenever we move towards the left child we will decrement it, so it will become -1 -2, and when we move towards the right child it will get incremented, so +1 +2 +3 like that. Okay, so now we are going to call this function. We'll call our helper function. So we'll create a function find, and what are the parameters that we are going to pass in this function is going to be the root followed by its position, which is going to be 0, and left and right, basically left and right arrays. Okay, so this function will just give us this left and right array filled with the positions of the leftmost and the rightmost nodes. Okay, and what we are going to return right 0 minus left of 0 plus 1. So this is the logic for vertical width. Now we will write a code for our helper function that is getting void. So why we are getting void? Because we don't want anything from this function. Find, and we'll pass, it will take root node root into position and left and right arrays in left comma int right. Okay, now the same thing, the edge case it is going to be same for both. So we're going to do this thing. Now we are going to fill our left array. So left 0 is going to be math.min of left 0 comma the position. Okay, and similarly right 0 is going to be math.max of what? Math.max of right comma 0 comma position. So what we are doing here is that suppose we are at this root node, so its position is going to be 0, and when we move towards the left node, so its position will become -1 with respect to this. So we are going to store the minimum of the two, 0 or -1. So math.min function will return as the minimum of that, so -1 will get stored in the left. Similarly, whenever we call, we'll make a call for the left child, So again it will move towards the left, so it will become -2. Now -2 and -1 we will check. So in this, -2 will be more smaller, so it will get stored in the left array. So this is how we will get the location of or the position of the leftmost node in our binary tree. And same goes for the right, that here we are using mat.max, so it will check in 1 and 3. So uh, it will check in 1 and 3, and we will get that here it is 0, its position reference is 0, and here it will become 1. So among these two, 1 is greater, so it will get stored in the right. Similarly, we'll make we will generate calls for right child, and at last we will get the position of the rightmost node in our binary tree. So now what we can say, calling left function. Okay, calling left function. So find will provide root dot left, comma. Now since we are moving towards the left, so it will become position minus one, comma, the left and the right array we are going to pass. Left, comma, right. Because usually we are calling, and in order to call right child, what we are going to do, find root dot right, and the position will get incremented by one, comma left, comma right. And since it is void, so we need not to return anything, and we have done a typo here. Okay, so that's the whole thing. Now we are going to submit this thing. So it is showing an error. If root is equal to null, return 0. Okay, okay, so we need not to return anything. If root is equal to null, we just need to leave it. Okay, so compiled successfully. Now we are going to submit this thing. So it will get submitted also. So thank you.